Hi, welcome to Factorising more quadratic trinomials, and in this example what I've done is I've picked out the last term to be negative and the x term to be positive. So how do we factorise trinomials like this? Well, first of all, when you've got to factorise absolutely anything, first thing I would always encourage you to do is check to see whether you got a common factor. And in this example, you'll notice that 10 goes into each one of these three terms. So what I would start off then with is to write out the expression 30x squared plus 130x minus 100 and say that this is identical to 10 bracket, and then we need 3x squared inside here plus 13x minus 10. That will give us this. Now, is this fully factorised? Well, we've got a quadratic factor here, and this quadratic factor will in fact factorise again. So how do we factorise this quadratic factor? Well, we know that it's come from, say, expanding two brackets, and in the usual way we must choose two x terms at the front here that multiply together to give the 3x squared. And that's got to be a 3x and an x. 3x times x will give us the 3x squared that we require. It doesn't matter actually if you had x or 3x there. It doesn't matter which way around you do this, it will still give 3x squared. So I've just chosen to put 3x in the first bracket. Now we need to pick two numbers that we put here and here that multiply together to give you minus 10, the minus 10 that we have here. Now there's lots of combinations that give minus 10. Let's just show you. The thing is about being minus 10, they've got to have opposite signs. Like for instance, you could choose, say, plus 10 times minus 1, or you could choose minus 10 times plus 1. And don't forget, you can swap these numbers around. You could have, say, a 1 times a minus 10, or a minus 1 times a plus 10. Now not only do you have those combinations, but you also have like the 5 and the 2 combination, say a plus 5 times a minus 2, or a minus 5 times a plus 2. Or you could swap it round again. You could have a plus 2 times a minus 5, or you could have a minus 2 times a plus 5. So which of these combinations is it going to be? Well, let's just dive in and choose, say, the top one, 10 and minus 1. Let's put plus 10 here and minus 1 here and see what happens. Don't be afraid of just taking a guess. Well, we know we've got the 3x squared, we know we've got the minus 10. It's the x terms that we're really interested in now. That's that loop there, 3x times minus 1 and 10 times x. Well, 3x times minus 1 is going to be minus 3x, and plus 10 times x is going to be plus 10x. And what does this give us? Well, it gives us plus 7x, not the 13x that we wanted. Now you might be tempted to say, oh, I'll change the signs. But I'll show you what happens. If you change the signs, all that happens is that you end up with just, not as we had here, 7x, but you end up with minus 7x, because 3x times 1 is plus 3x, and minus 10 times x is now minus 10x. So you retain the same values of x, but just opposite signs here, which leads to an opposite value as you had before. So this time we've got 7x instead of the minus 7x. So really what I'm trying to say is swapping signs isn't really your highest priority. Your highest priority is to get that number, the 13, and then worry about whether you've got the right sign. If you've got the wrong sign, you just switch the signs. Okay, so it's not a 10 and a 1. But is it a 1 and a 10? Let's swap the numbers around, okay, and not worry so much about the sign. So 1 and, well, we've got to keep that as a plus, so we'll have that as plus 10. So what have we got now? We've still got minus 1 times 10, which is minus 10, but the x terms, we've got 3x times plus 10, which is plus 30x. Let's just give that a bit more room there. And minus 1 times x, which is minus 1x. And we've now got 29x, not the 13x that we wanted. Switching the signs will only give us minus 29x, so that won't be worthwhile doing. Okay, so we've tried the 10 and 1 combination, and the 1 and 10 combination doesn't work. So we've got to try a 5 and a 2 combination, and if that doesn't work, a 2 and a 5 combination. Okay, so let's try a 5 and a 2 combination. Again, don't worry too much about the signs, okay, because as long as they've got opposite signs here, different signs, that will give us the minus 10. What have we got this time as far as the x terms go? 3x times 2 plus 6x. Minus 5 times x minus 5x. So we've got 6x take 5x is just 1x. We wanted a 13. So it's not going to be a 5 and a 2 combination, but maybe it's a 2 and a 5 combination. So we'll change those to a 2 and a 5. Alright. What have we got now? Still got the minus 10 on the end. No problems there. As to the x's, 3x times plus 5 is plus 15x. Minus 2 times x, minus 2x. 15x minus 2x, 13x. There you go. Got it. If we'd had the wrong signs here, plus here and a minus here, all we'd have got would have been minus 13x, and we would have known that we've got to switch the signs only. Okay, well, we've got it there then. So all we need to do now is just finish this off by saying this is identical to, put your identical signs underneath one another. The 10 goes there, and then we can factorize this into two other brackets. These are often called linear factors now, by the way. So the first linear factor is 3x minus 2, and the second linear factor is x plus 5. So there you go. 30x squared plus 130x minus 100, fully factorized, is this. Okay, well, that brings us to the end of this tutorial, and in my next tutorial I'm going to show you how we deal with factorizing trinomials, quadratic trinomials, where this term, the x term, is negative and the constant on the end is also negative.